Welcome to lesson on 6.4, factoring polynomials. We'll be exploring the ways to factor polynomials and how is factoring useful. In order to factor, we need to sort of remember the order of factoring. The very first thing you should always do is look for GCF, the greatest common factor of all the terms. And if GCF exists, then we need to do that first. And then generally we try to recognize a special kind of factoring. There are four kinds that we're responsible for this class. The first is the difference of squares. Think of factoring as backwards expansion, right? We've done x plus b times x minus b, which is a squared minus b squared. And then we know that therefore a squared minus b squared has to be a plus b times a minus b. So these are the things that we've seen before, right? When you see a squared minus 2ab plus b, that is a plus b squared, and that is called perfect square trinomial because you're squaring something, right? It's called perfect square. And when you expand it out, we end up getting trinomial. And I generally do cubes the same way. The form is almost the same. A cubed plus b cubed gives you a plus b without the cubes, right? And the right-hand side becomes a squared minus ab plus b squared. Remember, there's 1 in the front, not 2. And then the signs are flipped for difference of cubes. A cubed minus b cubed is a minus b times a squared plus 1 ab plus b squared. And the last but not least is when you see like multiple terms, maybe more than 3 terms, please consider looking at the grouping. Okay. All right, guys, let's get started with factoring out GCF. What do you see in the A? So you look at 6, 15, and 6. What do they all have in common? 3, right? And then we have x cubed, x squared, x has x in common. So we factor out the 3x, and then we look at this right there, and that looks like it's factorable, right? So we have no choice with 2x squared, so it's 2x and x. And what is a multiple of 2? Either 1 and 2 or 2 and 1. As it turns out, that plus 1 plus 2 works great, and that is the factor form. Going over in section B. Oh, by the way, I'm expecting that you will sort of pause the video between the problems so that you will try them on your own, right? Okay. I'm assuming that you just unpause the video. Here, so my GCF is between 2 and 18, we have 2 in common. And then x cubed and x has x in common. So it's 2x. When you factor that out, you get x squared minus 9. And this one over here, when you mess around, it's x and x. What multiplies to 9? Either 1 and 9 or 3 and 3. As it turns out, 3 and 83 works great, and you won't, and the middle term cancels, right? Or what you could have done is simply have memorized the difference of squares, right? Good. All right. Like for 2a and 2b, even if you forgot to memorize that, you could sort of figure it out by sort of like, messing around a bit. But for the cubics, it's a really good idea for you to memorize it. In fact, you should memorize all 4. All right. In this particular case, what do you see? I notice that the first term is x squared, and the second term, 64, is also a square. So that could be written as x squared minus 8 squared. And you could just use the form over here, right? Which would have given you x plus 8 times x minus 8. But here I'm just going to like mess around a bit. And when you do, it turns out to be x plus 8, x minus 8. But I think it would have been wiser for us to memorize the form. Now, b definitely is cubic, right? Because the entire 2x cubed is 8x cubed, and 27 can be expressed as 3 cubed. And then we're going to apply the form right here, guys, right? So when you see that, 2x is like a, and 3 is like a b. And then for any time you see a, we plug in 2x. Anytime you see b, we plug in 3. When you go through the process, this is what you end up with. So 2x squared is 4x, and 3 times 2x is 6x. 3 squared is 9. We may need some more practice on cubics because traditionally students have found this difficult, but I think with a little bit of practice, we should be all right. Last but not least, factor by grouping. When you do that, generally speaking, grouping the first two and the last two should work. In some cases, you have to mess around a bit. It could be like first and the third or first and the fourth, okay? In this case, the first two looks fine. And what do these two have in common? X squared, right? And then x plus 1 has 1 in the front. And when you see the two terms that are in common, factor that out, write that out first. And then you ask yourself, what's remaining after you take that out? X squared and plus 1. Okay? Now, it's not over yet. Ask yourself this question. Is x squared plus 1 factorable? Does it fall into any one of these categories? When you examine a bit, you realize it doesn't, so we are safe to move on. Let's look at B. Once again, here, the first two and the last two should work. What's common to the first two? If you set x squared, that's wonderful. Now, and chances are the x plus 2 is the factor to both, so I want to have x plus 4 here, but it's not. So what do you have to factor out from here to have x plus 4? If you set minus 1, great job. And now we got to factor out the x plus 4 from both sides. And what's remaining? X squared minus 1. So the most common mistake here, you did all this hard work to get to this point. You just forget that, oh, gee, I'm done, right? No, we're not done. You have to examine, is there anything else we could do? And when you look, x squared minus 1 looks, because 1 is 1 squared, right? So that looks a lot like difference of squares. So we'll go through that process, and now we're done. So the final answer is x plus 4 times x plus 1 times x minus 1. I know there's another page or two, but we'll do that in class. Thank you for watching, and I'll see you tomorrow. Have a good night.